All right, in this video, we are going to start on Calc AB Notes 27, which is partial fraction decomposition and then antiderivatives that are related to that. So this is not a Calc AB topic. We do it after the AP exam. If you're in Calc BC, this is definitely a topic that you need to know. I feel like it's kind of like a Calc 2 topic if you're in college, but let's see what we're talking about. So the name of these notes, partial fractions and a ton of natural logs, seriously, because there are going to be a lot of natural logs when we find our antiderivatives. So what is partial fractions talking about? Well, you start with something that kind of looks like this thing, and the question will be like, find the antiderivative of that. And you look at it and you're like, well, I can maybe let u equal x plus 3, but that's going to be weird. I could let u equal x minus 2, equally weird. I could try to expand it and let u equal the whole denominator, but then du is not going to work out. But it looks like this is sort of like a common denominator situation, right? It kind of looks like you had something over x plus 3 plus something over x minus 2, and you combine those, and magically the numerator becomes a 1 when you find that common denominator. But the question we want to answer is like, what did you start with? So that's the actual question that we want to answer. What did we start with? Because if we could figure out what we started with, maybe we could work with that instead. So that's what we're going to try to do. So what we do is something called partial fraction decomposition. So the way that you do it is you start off with that idea, right? 1 over x plus 3 times x minus 2 should have been something over x plus 3 plus something over x minus 2. They need to be proper fractions. So for a proper fraction, the degree of the numerator is less than the degree of the denominator. So the denominator is linear, right? So let me write that down, I guess. Whoa. Okay. So denominator is linear. So for it to be a proper fraction, the numerator must be, that says must be constant. So if the denominator has a linear factor, the numerator at most could be a constant for it to be a proper fraction. So that's the basic premise. So we say, all right, so we had some constant that we're calling a over x plus 3 plus some constant, which we're calling b over x minus 2. When we combine those, somehow we get 1 over x plus 3x minus 2. So how can we solve this? Well, I can clear out the denominator. So that's what I'm going to do. I'm going to multiply both sides by this. So we're multiplying both sides by x plus 3 times x minus 2. When I multiply the first fraction by that, the x plus 3's cancel, and I'm going to get x minus 2 times a. When I multiply the second fraction by that, the x minus 2's cancel, and I get x plus 3 times b. And then on the right-hand side, if I multiply by the denominator of the right-hand side, I just get whatever the numerator is. So I just get 1. Okay, so what can I do here? I can expand. So this feels similar to when you are solving differential equations, right? So you equate coefficients. So I'm going to expand. If I do that, I will get ax minus 2a plus bx plus 3b equals 1. Okay, let's kind of like factor this a little bit. Well, a very little bit. So we'll get the quantity a plus b are the coefficients of x, and then minus 2a plus 3b, and that should equal 1. All right, so what can we do? Well, on the right-hand side, there are no x's. So that means from the coefficients of x, so I'll use a different color. Coefficients of x, right? We get a plus b equals, there's no x on the other side, so 0x, and the coefficient is 0. So a plus b is equal to 0, which is really good because we can use that. And then also from the constants, we know that negative 2a plus 3b equals, on this side we just have 1. All right, so if a plus b equals 0, then we know that a is equal to negative b. So I'm going to say this will become negative 2 times negative b plus 3b equals 1. So that's 2b, so 5b equals 1. So now I know that b is 1/5. And if b is 1/5, then a is the negative of that, so a must be negative 1/5. All right, so was that great? That was not super great. That's the process though. That process will always work. Let me introduce a different idea though, right? So, well, let me just kind of like finish the problem, right? So it was a over x plus 3. So this integral, what can I do here? Kind of, I've infringed upon my space. Let me move this up and over. All right, it's kind of out of the way. So this original integral should be the integral of a was negative 1/5 over x plus 3 plus b was positive 1/5 over x minus 2 and then dx. Okay, and this you can integrate because you actually, now maybe you're getting a sense of where all these natural logs are going to come from. Both of these integrals result in natural logs. So the one thing you could potentially mess up is the chain rule. The other thing is forgetting absolute values. So I'm going to get, what the, see that? Perfect circle, but I didn't even want it. Plus 1/5 natural log of the absolute value of x minus 2. And then plus c. Don't forget your plus c. All right, not the end of the world, right? So this is the process of partial fraction decomposition. If you're in Calc BC, you will never do anything more than non-repeated linear factors. This is the worst that it will get, what you're looking at right here. The only thing that could be different is like you could have 2x plus 3 and 5x minus 2, some like gross things. But I want to return for a second to this part right here, right? When we got here, there's actually something we could do. And at that point, so what color was that? Okay, so we had x minus 2 times a, x minus 2 times a, plus the quantity x plus 3 times b. And we knew that was 1. All right, so what if we made an amazing choice of x? What if I said, let x equal 2? Okay, why would I choose 2? I'm choosing 2 because if x is equal to 2, then this part is 0. And that means that I'm just going to end up with 2 plus 3 is 5b equals 1. So b is 1/5. Okay, well, what if I make a different choice? What if I say, hold on, I'm looking for good colors. Okay, what if I say, let's let x equal negative 3. Let x equal negative 3. Well, that'll mean that this part now is 0. And so I actually just get negative 3 minus 2 is negative 5a equals 1. So a is negative 1/5, which is so much less work, okay? This is halfway to something called the cover-up method. So what is the cover-up method? How am I going to show you this when I can't physically cover things up? So what I'm going to do is, what am I going to do? 1 over x plus 3, x minus 2. You know what I'm going to do? There's like an extra page usually at the end of the, oh, and there's not this time, so that's great. Can I add a page? I can't even add a page. All right. Okay. I have no space in which to do this. Let's move this. If I move this, I think I got enough space. Move this over here. And then new color. Well, not new color. I'm going to go back to black. Okay. So we had a over x plus 3 plus b over x minus 2 equals 1 over x plus 3. We're going to do this with highlighters as best we can, x minus 2. Okay, here's what we do. You look at the thing that is underneath a, right? The thing underneath a is x plus 3. So what you're kind of doing is you're instead of multiplying both sides by the common denominator on the right-hand side, you're going to multiply first by the denominator of just like the a fraction and see what happens. then just the denominator of the b fraction and see what happens. Then you make your kind of like judicious choices, but it's called the cover-up method. Here is how it works. So I'm going to cover up. So underneath this, underneath a is x plus, underneath a is x plus 3. Okay, so what makes that 0? What makes that 0 is -3. So I'm going to let x equal -3. Okay. I go over, so this will give me the value of a. A is equal to, I go over here and I cover up the x plus 3, and I sub in -3, and I get -1/5. Okay, that's the cover-up method. You literally kind of like put your finger on it. So you look at a over x plus 3. You say, what makes that 0? It's x equals -3. Go over to the other side, cover that factor up, and now substitute in what made that factor 0, and you get a is -1/5. Let's try another one. So I look at b, right? So b, the denominator is x minus 2. So what makes that equal 0? Let x equal 2. This is going to tell you what b is. Now you go over here and you cover this up, and you substitute 2 in for every x that remains, and you get 1/5. This is called the cover-up method. It's called the Heaviside cover-up method, which like is spelled like heavy side. Maybe it's like Heavi. I don't know. Google will know it, right? So try to type it in. That's a cover-up method. So I'm going to use that extensively when we start doing the problems, and I'm going to cut this video here because that's like the explanation. I'm going to come back in the next video. I'm going to do the problems that are on the page, and then we'll keep rolling. So I will see you in the next video.